Hey guys, how you doing? Uh, Welcome to this video, which is about deep learning. I posted a video about machine learning a while ago, and continuing in the same sequence, this is about deep learning. And without wasting any time, let's get started. What is deep learning? Well, deep learning is a subset of machine learning that focuses on training artificial neural networks to recognize patterns, make predictions, and learn from data without explicit programming. It is inspired by the structure and function of the human brain, using multiple layers of artificial neurons to process information. How does deep learning work? Deep learning model consists of multiple layers of neurons, hence the term deep because of multiple layers. Each layer learns increasingly complex representations of the data. Input layer receives the raw data. The data can be images, text, audio. These are the few examples. Hidden layers extract hierarchical features through activation functions like ReLU or sigmoid. These layers perform feature extraction, pattern recognition, and transformations. Output layer produces predictions, example, classifications, labels, numerical values. So like all computer processing, this is divided into three: input, output, and processing in the middle, which they're calling hidden layers, right? And basically, deep learning is a subset of machine learning. So how it started was with machine learning is the first level of AI. That is where you are kind of starting to give the data and telling the machine or the computer of what is what, right? That is assistive learning. And then you have kind of the second one, whereas the computer starts to make its own pattern and do its own learning. And then there is a reinforcement learning, wherein you say, it's like reward and whatever, right? At least that is what we learned in the last video. And this deep learning is after all that stuff, right? This is kind of where human intervention kind of reduces further. In machine learning, there is still a lot of human intervention, right? Coming to this part now, why is deep learning powerful? Automatic feature extraction. Unlike traditional machine learning, it does not require manual feature engineering. So there we go, right? It does not require manual feature engineering, so less of human interaction there. Handles complex data, works well with images, speech, text, and videos. So yeah, videos are very complex data. I think they are the most complex because videos have images, speech, and text all combined, right? Scalability can process massive amounts of data with high accuracy. Okay. Backpropagation and optimization uses gradient descent and optimizers like Adam and SGD to minimize errors and improve learning. Okay. Hmm. So basically, I'm assuming backpropagation is that you go back and put the data back, you get a result, and then you go back and change the input, and that's how you kind of improve the output. Well, I'm auto learning. Key deep learning architectures: artificial neural networks (ANNs), basic neural networks used for structured data, convu convolutional neural networks (CNNs), specialized in image processing, example facial recognition, medical imaging. So CNNs, I always end up convolutional. The word is convolutional itself. I mean, recurrent neural networks (RNNs), used for sequential data like text and speech, example chatbots, voice assistants. Transformer models, the foundation of modern NLP models like GPT and BERT, used for language understanding. I think next video I'm gonna do about transformers. What are they? And I will try and learn more about it. Real world applications of deep learning, computer vision, face recognition, self-driving cars, medical imaging, NLP, chatbots, voice assistants, machine translations, speech recognition, virtual assistants like Siri and Alexa, autonomous systems like robotics, drone navigation, self-driving cars, etc. Deep learning versus machine learning. Here is a little comparison. Features. So machine learning is manual, deep learning is automatic. Performance on large data in machine learning, they say it's moderate. In deep learning, it's high. Computational power is lower. I think that's what machine learning needs lesser compute. So that's what it says lower, high, and in deep learning, it needs higher, needs GPUs. So that's where the GPUs come into the picture. Inter, interpretability, right? Ability to interpret it. This easy to explain. Machine learning, more of a black box. Okay, so the idea is that it's like LLMs, right? So you don't know what exactly is happening under the hood. That's what it says, more like black box. In machine learning, you kind of know what is happening. But in deep learning, it's the transformers. It goes and transforms the data into certain things, right? And how it processes it, it kinds of is unknown to the human brain. It's kind of like a zip file, right? You take 2000 TBs of data and you zip it into 200 GB, and it's like the amount of computational power that is now processing those 200 GBs would would determine the kind of output you get out of that data, right? So this is kind of a vague explanation. Challenges in deep learning. Data hungry, requires large data sets for good performance, computationally expensive, needs powerful GPUs and TPUs, lack of interpretability, hard to understand why model makes certain decisions. All right. Uh, and after that, so this is a breakdown, right? After this, we get into explained with detailed real world examples. So I asked it to give me some real world examples so that it would be easier for us to understand, right? So I'll start with number 6, finance and business applications. So it is like, okay, I will not read through it. I think it's very simple. Uh, it it learns from all the patterns, fraud detection and risk management, and stock market predictions. It says that it uses RNN, recurrent neural networks, and transformers to analyze historical stock trends. Hedge funds like Renaissance Technologies use deep learning for automated training. The examples can be vague, but let's understand that, all right, this is how it might work in theory, right? So deep learning can be used for fraud detection, to understand patterns, to, take out things which are, suspicious, right? So that's what they say here. Let's move on to the next example, which is autonomous systems and robotics, right? Deep learning is the core of intelligent robots and autonomous systems. Example, industrial robots and automation. Reinforcement learning and deep Q networks are the algorithms or the keywords which are being used here, which allow robots to learn tasks by trial and error. Reinforcement learning, I think we also learned in machine learning. Real world example, Boston Dynamics Spot Robot autonomously navigates terrains for surveillance and inspections. Amazon's warehouse robots use deep learning to sort of move packages efficiently, right? So these are like deep learning examples. So they kind of know, they would know that, okay, this is where a package is placed, or they are not supposed to go there again and again. If there are some changes in the warehouse layout, I'm hoping that the robot is able to learn the the change in the layout and able to manage itself, right? That's what it says. At least that's what navigate terrains for surveillance and inspections, right? So if the robots can navigate a terrain, they can navigate a warehouse, right? Reinforcement learning. All right, we are done with this. Coming to the fourth, generative AI, content creation and creativity. Deep learning enables machines to generate realistic images, videos, and music. ChatGPT, Sora, DALL-E, Midjourney, we know all about them. The deep fake thing, right? So deep learning is where the deep fake thing comes from. Even the music composition, so RNN and transformers again here, right? That's what they use deep learning to chat GPT. And again, I gave you the examples, right? And let's go to the speech recognition part, voice processing and synthesis. Deep learning enables machines to understand and generate human speech. Automatic speech recognition uses DNNs to convert speech into text, learns accents, speech patterns, and different languages. Very simple examples which we use on our daily life is Siri, Amazon Alexa, and Google Assistant. AI voice cloning and text to speech uses WaveNet by DeepMind and other generative adversarial networks (GANs) to synthesize realistic human speech. Real world example: Level Labs AI clones voice for audiobook narration. Deepfake voices are used in movies to recreate historical figures' speech, right? So that's all done by a AI. You train the AI. Like there is an artist. You give a lot of samples of their voice uh, to the AI, and it learns on those, and then it tries to replicate them. Natural language processing, text and speech processing. Deep learning enables computers to understand, generate, and translate human language. Chatbots, virtual assistants, they use RNNs. RNNs is a recurring keyword here. LSTMs and transformers. Example, GPT and BERT understands context, sentiment, and intent from text or speech input. Real world example, ChatGPT and Google Bard generate human like text responses for customer support, content creation, and more. Siri, Alexa, and Google Assistant process voice commands for tasks like setting alarms, playing music, and answering questions. And then you have language translations, right? Transformer-based models like Google's BERT and OpenAI's GPT analyze billions of text samples to translate between languages. Real world example, Google Translate and Meta's AI can translate less common languages using unsupervised learning, like whatever we post on Facebook, and it kind of translates and we can see the post like that, right? That I'm talking about Meta and Instagram. All right, and then we have the number one use of deep learning as per ChatGPT 4 point whatever is the buzzword these days. Computer vision, image and video processing. Deep learning powers applications that involve recognizing, classifying, and analyzing images and videos. Example one, self-driving cars, how it works. It uses CNN, convolutional neural networks, to process camera feeds, identifies road signs, pedestrians, and lane markings, combines with reinforcement learning to make driving decisions. Real world example, Tesla Autopilot and Waymo uses deep learning for self-driving cars, processing sensor data from LiDAR cameras and sensor, what kind of all types of inputs to navigate safely. Medical diagnosis and images, again CNNs, the convolutional neural networks analyze X-rays, MRIs, and CT scans to detect diseases. Deep learning can spot tumors, fractures, and abnormalities better than humans in some cases. Real world examples, Google's DeepMind AI can detect diabetic retinopathy, a condition that can cause blindness, from retina scans with over 90% accuracy. IBM Watson Health helps radiologists detect cancer in medical imaging. Facial recognition, how it works, that's another use case of deep learning. It uses DNNs, deep neural networks, to analyze facial features and recognize identities, extracts unique facial embeddings, example, eye distance, nose shape, eye distance, nose shape, and matches them against databases. Real world example, Apple's Face ID unlocks iPhones by scanning a user's face using deep learning. China's surveillance system uses AI-powered face recognition to track individuals, like the surveillance cameras, right? The dreaded cameras we kind of all heard about. So those were the examples of deep learning. And it is transforming industries by enabling machines to learn from data and perform human-like tasks, right? So I think for the time being, that's the end of this video. There is no way that anyone can learn everything about deep learning or any single thing of deep learning through one video or in a short time. However, I hope this attempt of mine would be a little help uh, in your learning as well as mine, because I'm also trying to learn and I'm just trying to read this, not pretending to be an expert. But let me know in comments if you have what is still here. Let me know in comments and what do you think about it. Yeah, bye.